this later. But anyway, so we're doing 701, simplifying radicals and factoring. Before you even do the warm-up, I would like for you guys to copy down the list of perfect squares 1 through 15. So copy down this list right here. We're going to be referring back to these throughout the lesson today. Okay, if you want to take a picture, you're more than welcome to. But you should have a table that is listed, number it 1 through 15. On the left side, numbers 1 through 15. On the right side, you are going to have in terms of square roots. Yeah. Yeah, you can write it on the inside of your cover page, or you can write it somewhere else, wherever you feel like you have empty space for this. Just make sure it's somewhere, because we will be referring back to this, especially during the warm-up. Okay. So take like, I don't know, a minute to copy this down, and we'll check back in. So we will be using these perfect squares. We'll be referring back to them during this warm-up. So let's take a look at the instructions in the warm-up. I'm going to have Brandon, if you could please read nice and clear where it says warm-up. Great. So does everyone understand what the word approximate means? Yeah, good. An approximation is an estimate. Like, I am approximating that there are about 40 students in this class. It may not be exactly 40 students, but close to 40. Or it's approximately 60 degrees outside. I don't know exactly what it is, but roughly 60 degrees. So anytime it's approximation, you're just getting close to it. It doesn't have to be exact. It doesn't have to be perfect. Right? So let's look at the first problem, the square root of 23. Obviously, the square root of 23 is not a perfect square, which, by the way, do we understand what a perfect square is? If not, let me tell you what a perfect square is. So there's a reason why we wrote this column down. A perfect square is basically a number that you can take the square root of. For example, 1 is a perfect square because the square root of 1 is 1, meaning 1 times 1 gives you 1. The square root of 4 is a perfect square because 2 times 2 is 4, where it's the same number multiplied by itself to get you the other number, right? So 9 is a perfect square because 3 times 3 is 9. 16 is a perfect square because 4 times 4 is 16. Does that make sense? All right, so it's the number times itself that gets you your answer. That answer is considered a perfect square. In this case, there is no number times itself, or at least a whole number times itself, that gets you to 23. So we're going to approximate this. And the way we do that is, well, the square root of 23, if we go back to our list of perfect squares, would fall in between what two perfect squares? Where would the square root of 23 go? In between, yeah, in between 4 and 5. Between the square root of 16 and the square root of 25. So which one is it closer to? Is it closer to 4 or is it closer to 5? It's closer to 5, but we can't say exactly 5. So what should we approximate it to be? 4.5 is not close to 5. 4 point what? 4.8. Let's do 4.8. So we're going to write this down. The square root of 23 is approximately 4.8. And we're going to graph it. Go to 4.8 on the number line and graph that. That's going to be the square root of 23. Okay? All right. I want you guys to try the next one. See what you get. You have 30 seconds. No. Sorry. Yes. Oh, yeah, there are napkins back there. Next to Miss Harini. So once again, you guys are trying B. Negative square root of 7. Let's go about 15 more seconds. Okay, let's look at the square root of 7. Where is the square root of 7? Where does it fall regarding our list of perfect squares? Where would it fall? Where would you place the square root of 7? Let me ask one of you guys, because let's see what you guys think. Shirey, what do you think? Where would the square root of 7 go? Between 2 and 3. Right here, right? Is it closer to 4 or is it closer to 9? A little bit closer to 9, so we could approximate it to be about 2 point what? 2.7, 2.8. Let's go with 2.7. Make that negative though. 2.7. So approximately equal to 2.7. And we can go ahead and graph it. Go to negative 2.7 down here. Plot your point. Negative root 7. Okay? All right. Any questions so far? Okay. Let's try C now. 100 to the 1/2 power. This should be reviewed because we have done this before. The denominator is telling us that we need 2 equal sized groups that multiply to 100. So what should each group have? 10. The numerator is telling us that we want one of these groups. So your answer is what? 10. Okay, so go to 10, plot a point, and that'll be 100 to the 1/2. Okay? All right. I'm going to show you how to do D, and then you guys will work on on E by yourself. Now, for D, I would like for you guys to copy the following rule down. When it comes to radicals, to square roots, there is a rule that you are able to condense a statement that has separate radicals into a single radical like this. So you can put the products under the same radical, as long as, of course, they're both being square rooted. So square root of A times the square root of B, both of which are right now they're separated. You can put them together. You can multiply them under a single radical. That's the rule. And so with that rule in mind, how could we solve D? We have the square root of 6 times the square root of 6. If I were to place this under a single radical, what would I have? 6 times 6, or 36. Now, here's the next question. What is the square root of 36? Is 36 a perfect square? Yes, the square root of 36 is 6. So we're going to go to 6, and we're going to graph that 6 times 6. Root 6 times root 6. Okay. What I would like for you guys to try now is I would like for you to complete E on your own. And it shouldn't take you any longer than 30 seconds. Yes, question? By next week. From second period so far, yes. Not that many. Okay, so if we condense root 2 times root 3 times root 2, we can put all of that under the same radical. 2 times 3 times 2. 2 times 3 is 6. 6 times 2 is 12. The square root of 12 is approximately equal to what? 3.4. Very good. So here in 3.4, we're going to put a point. Okay, and then here's the last question. And this one could be a challenging question, depending on how you see it. Can we find the square root of -1? What do we think? Well, if I multiply +1 times +1, what would I get? +1. If I tried -1 times -1, what would I get? 1. The only way I could get -1 is if I multiply a positive with a negative. But would that be the same number? No, that would no longer be the same number. So as it turns out, f is not possible. It is not possible to take the square root of a negative number. Now, just because it's not possible right now doesn't mean it's not possible ever. I'm going to make it possible for you guys in about 10 minutes from now when I introduce to you guys negative square roots. But for right now, in this warm-up, it is not possible. Okay? All right, so let's jump to some guided notes. I hope you guys have your perfect squares written down somewhere because we will be referring to those in just a second. So let's all look at the square root of 24. There's a few things that we could do here. By the way, we're going to be utilizing this rule. Once again, this rule that you can split things up. I don't know why it's coming out like that. 1 second. You can separate things into its products, right? So you can separate a number into its products. We can basically factor it out. We're going to utilize this rule for number 1. So 24, we're going to break down into its factors, meaning the numbers that multiply to 24. But I need you guys to think of the following, because it can't just be any factors. I mean, it could be, but it's going to be a lot more work. I want one of these factors to be a perfect square. So look at your list of perfect squares, and I want you to figure out if there are any numbers on that list of perfect squares that also happens to be a factor for 24. And when you get it, raise your hand. Yes, go ahead, Gabriel. 4. Very good. So I'm going to split up the square root of 24 into the square root of 4 times the square root of what? 6. Now, because the square root of 4 is a perfect square, I can solve that. The square root of 4 is 2 as a whole number. If I try to break down 6 any further, I would get the following. Square root of 3 times the square root of 2. Are either of those two perfect squares? No. So square root of 6 will remain, or it will stay as the square root of 6 because it cannot be reduced. Right? Cannot be reduced. Okay? So the simplest that we can rewrite the square root of 24 would be as 2 radical 6. Okay? Let's look at the next example now. 150. We're going to do the same process here of trying to make one of these a perfect square. Once again, at least one of these factors should be a perfect square. So look at your list of perfect squares and tell me which one do you think could work here. Go ahead, Noah. Okay, 10 and 15. Are either of those two perfect squares? 10 and 15 could work as factors, but neither of those two are perfect squares. 6 and 25 works better. 25 is a perfect square. So let's use 6 and 25. Now, that doesn't mean that you can't use 10 and 15. It just means that if you use 10 and 15, you have to do more work. Now, the square root of 25 is what? 5. And previously, we said that 6 cannot be reduced. So we will leave that as the square root of 6. giving us an answer of 5 radical 6. Okay. Now, don't write this down, but I'm going to do it the other way. Let's say that I had gone with Noah's numbers. Let's say I had gone with 10 and 15. I would have needed to break 10 down to 5 and 2. And then I would have needed to break 15 down to 5 and 3. Well, anytime you get a pair of square roots, they cancel out. So here we have a pair of square roots. That is going to be left as positive 5 as a whole number. And then anything that is left inside a radical needs to be combined together. So that would have been 5 radical 2 times 3 or 5 radical 6, which is the same thing that we got there. But look at how many more steps I had to do. Okay, whereas with 25 and 6, you know 25 is a perfect square, so you just simplify that and you're done. All right, with the other one, you have to look for pairs, which is a little bit extra work. But it doesn't mean that it's wrong, it just means extra work. So now what I would like for you guys to do is to try out 3, 4, and 5. Okay? Do not attempt 6 yet. Or actually, yeah, don't attempt 6 yet. I'll do 6 with you guys. So do 3, 4, and 5. You have a few minutes for that. So obviously I can see some of you guys are confused. Please follow along up here. If I want to split up 40, what would be 2 numbers that I can split 40 into? 2 and 20 or 4 and 10? Do I have any perfect squares here? Yes. What's the square root of 4? 2. If I try reducing 10, I'm going to get the square root of 5 times the square root of 2. Are either of these 2 perfect squares? No. So that means 10 cannot be reduced. 2 radical 10 is your solution. Whole numbers go on the outside. Any remaining radicals stay, or any remaining, I guess, numbers stay inside the radical. Okay? Let's try this one. Radical 18. What can I split 18 into? 9 and 2. Are either of these 2 perfect squares? You sure? 9's a perfect square. What's the square root of 9? 3. 2 cannot be reduced. 2 stays inside the radical. Okay. What about 225? Is 225 a perfect square? Yes. What is the square root of 225? 15. Finally, this one, which you guys didn't do. It's because I want you to write the following. Square root pairs cancel out. So anytime you have a pair of square roots, the square roots will cancel out. You'll be left with the number inside of the radical. So for example, here we have 179 times 179, right? But that's a pair of square roots. So that means that your solution is simply 179. The square roots will cancel, and you'll be left with the inside, 179. And the reason why this happens is because the square root is looking for 2 numbers of the same size to multiply for the number inside. If it were a cube root, then it wouldn't be a group of 2. It would be a group of 3. If it's a 4th root, then it's not a group of 3. It's a group of what? 4. If it's a 5th root, it's a group of what? 5. 5th root, 5. Okay. So you want to match the number according to your root. Square root, pair. Cube root, 3. Okay. All right. Let's move down to some notes on here. So if I asked you the following, can we solve the square root of negative 9? What would you say? No, we can't because it's negative. But what if we ignored the negative for just a second? and I said, okay, can we do the square root of 9? What would you say? Yeah. So it looks like the problem is a negative. So why don't we use the rule of splitting this into its factors to our advantage and rewrite this as the square root of negative 1 times the square root of positive 9. If we do this, now we're able to solve the square root of 9. Square root of 9 is 3. The problem is, what do we write for the square root of negative 1? And that's where this definition comes to play. The square root of negative 1 is an imaginary number represented by the letter I. So anytime you guys have a square root of a negative 1, you will replace that with the letter I. Okay? So that you guys know it's an I. Otherwise, if I do it like that, it looks like a 1. How does that look like a J? A J is the other way.
That's an L.
It can't be, it's, okay. Whatever works for you guys, I'm sorry. Fine, is that better? An I like this?
Yeah, that's way better.
Alright, whatever. So we have 3 and we have I. So this becomes 3I. Your solution is 3I. Sorry, let me replace that.
No, that one looks better. That one looks better. Little tail's not as long.
Okay.
There you go.
So we have 3I. Let's try the next one. Negative square root of negative 75. Let's begin by taking out the negative 1. Then let's factor the rest out. We have 75 that can be split into what?
25.
25 times what?
3.
Times 3. All right. We said the square root of negative 1 is equal to? I. Square root of 25 is? 5. And then can we do anything with root 3? Root 3? No, it cannot be reduced. Now, before you write your answer, there's a specific order that you need to follow. So write this down somewhere on your notes. The order is as follows. Whole numbers come first, followed by I, followed by any remaining radicals. Okay? That's going to be your order. Once again, it's whole numbers first, followed by any i's, followed by any remaining radicals. There is no part 2 for that exam.
No, from the last exam.
Oh. Okay. So what would the answer be for this one, you guys? What's the whole number? 5 followed by radical 3. So we get 5i radical 3. Let's not forget there's a big negative in front of the entire root, so you have to bring that down to make this negative 5i radical 3. Okay. You have 4. Please, quiet down. All right. So let's see. Radical negative 100. We can split this up to negative 1 times negative 100. And this is basically going to give you 10i. So that one could have been done in 2 steps. Next, negative 80 radical, or negative radical 80. We have the negative right here, negative 1 on the outside. Actually, no, you don't have to worry about that. Don't worry about that yet. Let's do 80. We have radical, I don't know what numbers you guys used. I don't want to go with 16 and 5, but you guys didn't use those. 4 and 20? Okay, let's do 4 and 20. Square root of 4 is 2. 8 to the 2/3, the bottom number in the denominator, like the denominator basically, is telling you that you want 3 equal sized groups that multiply to 8. So what would each group need to have? 2. So this is 2 times 2 times 2. And then the numerator, which is a 2, is telling you that you want 2 of these groups. So we have 2 times 2, which is equal to what? 4. So giving you an answer of 4. Now this is how we taught it to you guys. This is not how you guys or how people in other schools learn it, or even at like a higher college level or something like that. They teach it differently. There's a more procedural way. So 8 to the 2/3 technically is supposed to be done like this. The top number represents the exponent. The bottom number represents the root. So 8 to the 2/3 would need to be rewritten as the third root of 8, the cube root of 8 basically, raised to the second power. Now what is the cube root of 8? What number times itself 3 times gets you 8? 2. So we have 2 squared. And what's 2 squared? 4. And so you end up getting the same answer, but you're doing it a different way. In this second method, you have to identify the exponent and identify the root from the fraction that we give you. No. Okay, so now look at 14. Which of the letters here represents the exponent? M is going to be your exponent. N is going to be your what? Your root. So we have the nth root of B raised to the power of M. Okay, and this will be your answer. The nth root of B to the power of M. Now let's say that we want to go backwards. Let's say we want to go from like root form back to fractional form. Like this. In problem 15, fourth root of 7 to the third, which number represents the root? Of the 3 numbers here, which numbers represent the root? 4 represents the root. Thank you. Which number represents the exponent? 3. So we have 7 to the power of, remember in the fraction it's exponent over root. 3 over what? 4. This is your answer. 7 to the 3/4 power. Okay. Let's finish up with one more. In this problem, which letter represents the root? N is the root. Which letter represents the exponent? M represents the exponent. So we have B to the power of exponent over root. Okay. All right. You have 2 to try out in 1 minute, and then we're going on break. All right. So now we're going to jump to the next section, which is changing standard form equations to factored form. We will also be solving them. That is how we are essentially going to solve or to find the x-intercept. Now, looking at number 21, we need to identify the greatest common factor between 36x cubed and negative 4x squared. So I'm going to go ahead and set this up with the area model. Since most of you guys are familiar with the area model, I will write 36x cubed in the first box and negative 4x squared in the second box. And I'm looking for numbers and variables that I can take out from 36x cubed and negative 4x squared. What do you think I can take out from these? Like, what would I write right here?
4.
4 and what else? Well, what else can I take out from 36 and 4 aside from a 4? Think about the variables. What an x, but how many x's can I take out? 2. I can't exceed the lowest number of x's. So I take a 4x squared out. 4x squared times what would give me 36x cubed? 9x. And then 4x squared times what would give me negative 4x squared? Negative 1. So these are going to be your factors. We're going to rewrite these like so. Set them equal to 0. Since it is already in factored form, set equal to 0, then you're going to set each one equal to 0 as well. To make 4x squared equal to 0, what would that x need to equal? Once again, 4x squared equals 0. What would x need to equal here? What would that x need to equal? It can be. Nope, not 1. Anything times 0 is what? Thank you. So that means that this x needs to equal 0. To solve this one, we would need to add 1 and divide by 9. So you have two solutions. You have x equals 0 and x equals 1 over 9. Good. Next example. Y equals 36x squared minus 4. So same thing, we will start with GCF. What can I take out from 36x squared and negative 4? Sarah, what can I take out from 36x squared and negative 4? I can take a 9. 9 I can't take out from a 4. Bigger than 2 would be 4. Let's take a 4 out. 4, that would give us 9x squared minus 1. These are factors. Rewrite them. 4 parentheses 9x squared minus 1. Set that equal to 0. Now, because 4 does not have any variables, we can ignore it. 4 is a constant. So let's focus then on 9x squared minus 1 equal to 0. How would I solve this? Cisneros, how would I solve this? What would my first move need to be to solve 9x squared minus 1? Think of a SADMAP. Opposite of subtraction. We're already subtracting. Addition. What am I adding? Plus 1 on both sides. Thank you. Nine x squared equals 1. What's the next step here? Natalie, what's the next step? Divide by 9. We have x squared equals 1 over 9. The next move is going to be what? To get x alone, I would need to do what? Square root both sides. What is the square root of 1 over 9? Why don't we do the following? What is the square root of 1? Square root of 1. Square root of 1 is not 0. 1. Square root of 9. Thank you. I love this class. Okay, we get plus or minus 1/3. Next problem. This next one will be an Xbox method. So you guys will need to do the giant X first and then a box to factor. Let's begin with the giant X. You are going to multiply the first and the last term. What goes on top? Well, we have to multiply them. What's 3 times negative 8? With a positive 10 underneath. Negative 24x squared, 10x underneath. Two numbers that multiply to negative 24 and add to 10 that are not 6 and 4, because those 6 and 4 don't add to, I mean, they do add to 10, but they don't equal negative 24. 12 and negative 2, thank you. Let's fill out the box. 3x squared and negative 8. Then we have 12x and negative 2x. What can I factor from the top row? 3x squared and 12x both share a 3x. Negative 2x and negative 8 both share negative 2. So help me with the other ones that are missing. 3x times what gives you 3x squared? X. 3x times what gives you 12x? 4. Here are your factors. X plus 4 times 3x minus 2 equals 0. So this x needs to equal 4. Sorry, negative 4. And this x would need to equal 2/3. Two-thirds, we can solve algebraically. You add the 2, divide by 3. 2 over 3 is 2/3. All right, I'm going to show you one last example, and then we'll call it a day.
Yeah.
For me, not for you. You have to do the rest of this on your own. Okay, last one. So GCF is how we're going to do this one. We don't want to jump into Xbox method unless we can do GCF first. So what can I take out from all of these terms? I can take out negative 2. When I take out a negative 2, I'm going to get x squared minus 7x plus 12. That is a factorable trinomial. So throw the 12 on the top, negative 7 underneath, and you should have the following. So the two numbers that multiply to 12 and add to negative 7 are 4 and 3, both negative. So negative 2 times x minus 4 times x minus 3, set that equal to 0. And that means that x has to equal 4 and x has to equal 3. All right. So here is the next task. You with your group or with your partner or by yourself are going to complete pages 5 and 6. And if that is able to get done in the next 25 minutes, then I will not assign page 7 as homework. However, if you are not productive, then I will assign page 7 as homework and I will check next class.